Hello everyone. Do you know that you can add more inputs and outputs to the Arduino Nano PLC as a Modbus master? It can even get the values of Modbus compatible sensors or data acquisition modules. When the PLC Nano is programmed with any instructions from the Modbus instruction group, it becomes the master PLC. It can then access the Modbus slave data according to the OutC PLC Modbus address map as shown. MF1 is the Modbus function number 1 for reading coil and memory bit data from the Modbus slave. Here is the Modbus slave address. Offset is the starting point of the slave variable to be read, where 0 to 127 corresponds to arrow.1 to arrow.128 in the Modbus slave, and 128 to 255 corresponds to B.1 to B.128. N data is the number of variables to be read from the Modbus slave. B.1 is the destination location in the master PLC that stores the retrieved slave variable. Now, if N data is set to 8, arrow.1 to arrow.8 data in the slave PLC will be read to the destination location in the master PLC, starting from B.1 to B.8. Then you can set the baud rate as required, which should be the same as that of the slave PLC. 100 milliseconds is a good number for the timeout. Add a contact and a coil into a new rung with variables B.1 and arrow.1. Choose Nano V5 from the settings menu and the Nano port number. Setting the baud rate and Modbus address here is only important for the slave PLC. Then upload the codes to the master PLC Nano. For the slave PLC, add an SPWM to the program with these parameters. Add a contact and a coil into another rung with variables p.1.st and arrow.1. Ensure that the baud rate and the Modbus address are the same as set in MF1 of the master PLC. Then upload the code to the slave PLC Nano. Set up the Modbus point-to-point connection with the TX pin of the master PLC Nano connecting to the RX pin of the slave PLC Nano, the RX pin of the master connecting to the slave TX pin, and then their GND pins. The TTL to RS485 converter module will be required to connect more than 2 OutC PLC Nano. Connect a push-button switch to S.1 of the master PLC and an indicator lamp to arrow.1 of the slave PLC. Observe that before linking both Nano communication ports, the TX LED on the Nano is flashing fast and the indicator lamp on the slave PLC is flashing steady. The TX and RX LEDs become steady on in both Nano when communication has been established, and the indicator lamps in both PLC are now flashing at the same time. MF5 is the Modbus function number 5 for writing data to a memory bit variable in the Modbus slave. Add a contact and a flip on rising instructions to the rung with variables S.1 and B.1. Add the MF5 instruction to another rung. Leave the slave address as 1. Change send to offset to 128, which corresponds to B.1 in the slave PLC. From is the data to be sent to the slave PLC, which we will set to B.1. The baud rate can be left at 9600, but change the timeout to 100 milliseconds. Then upload the codes to the master PLC. Always ensure that the communication ports are disconnected before uploading to the Nanos. For the slave PLC, delete rung 1. Change the contact variable to B.1 and the coil variable to arrow.1. Ensure that the baud rate is 9600 and the Modbus address is 1. Then upload the code to the PLC. Connect the communication ports of the Nanos as before. When pressing the push button switch on the master PLC, observe that the indicator lamp on the slave PLC is flipping its state. Thanks for watching. We will see how the analog and digital inputs are read from the slave PLC in the next video. Hope to see you soon.